So what we have seen so far is switching is moving packets based on MAC address, destination MAC address. To understand that, we have taken a switch here and we got 6 devices connected and they have got MAC address. They have also got IP address 10.0.0.1, 10.0.0.2, 10.0.0.3, 10.0.0.6. All the 6 computers have got IP address. But they're all in same subnet, right? So there is no need for a router. They're all in same network. To communicate between these devices, a switch is more than sufficient. Now we have a switch. Switch has got port names F01, F02, 3, 4, F05, 0/5, F0/6. Now let us say A is trying to talk to D. A tries to talk to D. See, this is very first conversation between the device. The switch is empty. Switch has got a table called MAC address table. And this table is empty. The table is empty. Initially, it is empty. So far, no packets passed through this switch. But now A is initiating a traffic to D. What will be the source MAC address? What is the source IP address? 10.0.0.3. What is the destination IP address? 10.0.0.6. And what is the source MAC address? AAA. What is the destination MAC address? DDD. Through RPTAS, already learned MAC address assume. So A puts the MAC address of the destination, the MAC address which it learned earlier through R. Now, when this packet approaches this port, switch will learn the source MAC address. It learns that on F00, a MAC address called AAA is connected. A device with a MAC address called AAA is connected. And the switch wants to now forward the packet to this destination, looking for the destination not available. When the destination is unknown, you need to remember this statement. When the destination is unknown, switches will flood. Switches will flood the traffic. In another word, switches will broadcast. What is broadcast? Sending to everyone connected to the switch. Sending to everyone connected to the switch is what we call it as broadcast. Now this packet goes to everyone. Will this B receive it? Will this B accept it? No. Why? Because the destination MAC address is not matching with its own MAC address. So it won't open the packet further. B receives the packet, tries to process it, but before processing it will check whether it is for B. No, it's not for B. So B will drop the packet. Same way, C will also drop the packet. F will also drop the packet, E will also drop the packet. But they all received the packet. They opened it. They checked the packet's destination MAC address, compared with their own MAC address. Not matching, not matching, not matching. So they drop, 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 drop. The only device that is going to process further is D. So D checks its MAC address. It is matching with the incoming packet's destination MAC address. Now it checks the IP address that is also matching. Now D knows that this packet is mine. So whatever the packet is asking for, now D will provide. Now let's say you are pinging. You are pinging from here 10.0.0.6. So it's a ICMP echo request. What is coming is echo request. Request. Now they have to reply back. This echo reply. We call it as ping. If the destination whom you're pinging is present, if it is present, it will respond with echo reply. The reply comes. Okay, the reply has come. What will switch do? Switch will now see who is talking to me on F04. The reply packet will be like this. Source IP 10.0.0.6. To whom it is replying? It is replying to 10.0.0.3. What is the source MAC address? Its own. What is the destination MAC address? A's MAC address. So it's a reply, no? A only requested, so to A it is replying back. So when this packet approaches F04, what switch immediately does this? It looks for the source MAC address, learns the source MAC address on that port F04. And now where the packet needs to be sent, it needs to be sent to A. Do I know about AAA? Yes, I do. I do. Where is that AAA? It's on F01. Look at this. This is what I was talking about. Switches takes the forwarding decision. This time it is not flooding. It is forwarding the packet straight to F01 based on the destination MAC address. When the MAC table is fully updated, for example, after some conversations between all these computers, switches very well know who is connected where. Switches very well know who is connected where. Like this, AAA, DDD is connected via F04. Likewise, when B speaks to C, it learns that BBB is connected to F02, CCC is connected to F03, and EEE is connected to F06, and FFF is connected to F05. It learns. Switches learns the MAC address because it knows who is connected where. When the packet arrives, it will forward the packet based on the destination. Okay, you want to go A, fine. I will forward it via F01. And if a packet arrives from here, wants to go to EEE, it looks into the table. Okay, EEE is an F06. So it's pushing the packet out on F06. This is what I meant when I say switches take forwarding decision based on destination MAC address. So MAC table, once it is fully updated, there is no more flooding, no more broadcast needed. Only when destination to a packet is unknown, that packet will be flooded to everyone. What does that mean? When the destination is unknown, the packet will be flooded to everyone means the copy of that packet will go to everyone. A copy. It will duplicate that many number of ports and flood it via all ports. That is what called as flooding here. That is what called as unknown packets are broadcast. When the destination is known, when the destination of a packet is known, when the destination MAC address is already there in the MAC table, there is no need for forwarding. And this is not new to you. Earlier during the device classes, we learned these things. If you go back and see, you might have uh, written in your notebook or video is there. If you go back and see before routing, before routers, we learned bridges and switches. There I was talking about this. Right now, switches needs only the MAC address for forwarding. But the packet to go from A to B, IP address is also needed. Because the switch is not using MAC address, sorry, because the switch is not using the IP address, it doesn't mean that you no need IP address at all. No, no, no. You need IP address for communication between these computers. But for switch to decide which port I should send out the packet, via which port I should send the packet out, it needs only the MAC address, destination MAC address of the packet. This is what we call the switching, and today our topic is switching. Switching. In switching, we learned in the beginning, it listens to the port, learns the MAC address, it forwards, it filters, it floods, all the stuff we learned. Now that is not our topic of the day. This I just did for you to recall things that we learned in the beginning. Now, going to the actual subject of today's class. In switching, what we are going to learn is called VLANs. VLAN. VLAN. When you say switch is a layer 2 device, right? There is also another name for the switch. You know what? LAN device. LAN. One switch is one LAN. What is the other meaning of it? In one switch, you have one broadcast domain. All are connected to a common backbone. One LAN. They're all in one LAN. That is what it means. Switching. Switch is a LAN. If I have 24 port switch, all 24 port is connected to this one backbone. That's why we call one broadcast domain or one LAN. Switch is a LAN device. This is one LAN. But if I want to create more groups in my office, assume I have a big switch. Inside the switch, it's a big switch, so there are many ports. There are many ports. Inside the switch, there are many ports. You know, 80 ports, let's assume. You have 80 port switch. Now, I have like 4 or 5 departments. In each department, I don't have more than 10 employees. Let's say I have 5 departments, and in each department, I don't have more than 5. So, sorry, 10 people. 10 person per department. Okay, now let us call that first 10 people 8, 9, 10. These 10 ports, department 1 people are connected. Now, if I connect next to 10 people, here, will it be safe? Will it be secure? No, it won't be secure. It won't be safe. Why? They are in single broadcast domain. Both are connected to single, both the departments are connected to single broadcast domain. Not good. There is no security. It's not safe. Let's say for this department, you gave 10.0.0.1 and slash assume just, for simple subnetting. I'm saying slash 28. When you have 28, how many IP addresses you will get? 15 IP addresses. So it's the increment of 8. Is it 8? No. Increment of 16. Yeah, 16 increment, yeah. And for this computer, you have given 10.0.0.17/28. Are they same network or different network? Answer. Is 17 and 1, are they in same subnet or different subnet? You know subnet. No, how you are saying same? Listen, it's /28. 10.0.0.0, 10.0.0.16, 10.0.0.32. This subnet is what I have written here. The first IP is 10.0.0.1 and the broadcast is 10.0.0.15 and the last IP is 10.0.0.14. I get 14 IP address. I said in a department there is no more than 10 person. This is for the first department and the second department dot 17. The subnet are the same network? No, they are not. Correct? They are not same subnet. Do you agree? So, they are in different subnet. That is true. That is true. But what if When when they are in different subnet, they will not be able to ping. That is true, no doubt in it. But what if they go to a router here? Router will make them connect. The router will make them connect. How and all we will talk later. What I'm trying to say is router will also have something called access control list, which will stop them talking. Unless there is a permission given, they cannot talk. Now, keep those things away from your mind. Now focus only on VLAN. You see, all these ports are in single broadcast domain, and we think that we have given them different IP from different network, and they won't talk. You may think that they won't talk, but to make them to talk, what this fellow will do if he's very desperate. Let me call it as A and B. A and B cannot talk now, even though they are in single broadcast domain, even though they are connected to single group. The ports that are in single group, they cannot talk because this is in different network. When they ping, they won't ping. But if they want to ping, if they want to talk, what this fellow will do, what this B will do, he will cleverly change his IP address to this subnet. Okay, let me use 14. If he changes his 17 to 14, now no one can stop him talking because he's in same network. He's in same network. Now, what do you understand from this? Subnetting alone cannot provide you isolation between the departments. Subnetting alone cannot prevent this department talking from that department. If you think that I have given them different subnet for each department, don't take it as granted. It is not fully secure. What if that employee in that department changes his IP address to match with another department? He will be able to talk. No safety, no secure, not secure. So what is needed? We need to create, I said a switch means LAN. Now I need to create virtual LAN. I need to make this 10 ports as one LAN, this 10 port as another LAN. Look at this. It's the same physical switch. Logically, it is physically, it is one physical switch, but logically, this 10 port is one switch, and it is identified with a number, let's say VLAN 100. And for this, I will give VLAN 200. Because they belong to two different VLAN, they cannot talk. What is two VLAN? Two broadcast domain. One VLAN is one broadcast domain. By default, all the ports of the switch belong to one broadcast domain. But now what we did is we created two VLANs, one called 100, another called 200. And we have taken these 10 ports and we have allocated to VLAN 100. And we have taken another 10 ports and we have allocated that to VLAN 200. Each VLAN is as equal as a switch, a separate switch. Now they belong to two different broadcast domain. I repeat, one VLAN is one broadcast domain. One VLAN is one virtual switch. They can't talk. Even if this guy now changes the IP address to 14, he cannot talk because they are not in same broadcast domain. They may be in same subnet. Layer 3 Yeah, they are in same subnet 14 and 1/28. It's same network. But in layer 2, they are not in same subnet. So they cannot talk. Yes. They cannot talk to each other now. These two are in two different broadcast domain. Even though the network is same network, 1 and 14, because they are in different broadcast domain, they cannot talk. This provides a good security, you see. So just giving different network is good, but that's not enough. You also need to put the departments in different switch, but you cannot buy a dedicated switch for each department. What you can do is you can create a virtual switch inside the switch, which is called as VLAN. Each VLAN is a broadcast domain. They have their own broadcast domain. What I'm trying to say is if these three ports are in one VLAN, which means these three forms one broadcast domain, and there is one disconnection between the other. This is another broadcast domain. See, there is no connection, there is no connectivity here. So these two cannot talk. They cannot talk because internally, logically, you put them into different island, different broadcast domain. நல்லா பேசின்னு இருந்தாங்க தமிழ்ல திடீர்னு ஒரு பூகம்பம் வந்துச்சு அப்படியே ரெண்டா பிரிஞ்சுது தமிழ்நாடு இந்த பக்கம் ஆஸ்திரேலியால போய் ஒன்று ஒட்டிக்கிச்சு இந்த பக்கம் துபாயில போய் பாதி ஒட்டிக்கிச்சு என்னதான் தமிழ் பேச தெரிஞ்சாலும் ஆஸ்திரேலியால இருக்கிற இப்ப துபாயில இருக்கவனோட பேச முடியாது கடல் பிரித்து விட்டது two different islands. You see, even though they may have same network IP address, though they both speak same language, they cannot speak now because they are in two different islands. Even if it is a very next port, these two cannot talk. Why? This belong to another island. VLAN 300. So this PC and this PC cannot talk because they are in two different logical switch. A VLAN is a logical switch. It's not a physical switch. It's a logical switch. It isolates one VLAN member talking to another VLAN member. The true isolation you can see. This is as equal as buying many physical switches. Why will I buy many physical switches when I have many ports available and when I can do VLAN? Yeah, it's good to do VLAN. Now tell me how many VLANs are in our switch? Is it 2 or 3? Here I see VLAN 100, here I see VLAN 200. What do you think? How many VLANs do we have in the switch totally? See, we have only 2 VLANs, I agree. Created 100 and gave these ports to all these ports to VLAN 100 and then created 200. I gave all these ports to 200. That is true. But do you remember? We saw that every switch will be having one broadcast domain. Then what is that broadcast domain? What is that VLAN to which all the ports are by default member? That is called VLAN 1. See, all the other ports except this 10 port and this 10 port, except these 20 port. Rest of the ports are in a default VLAN called 1. Yes. If I have 24 port switch, all 24 port will be a member of VLAN 1. So totally three VLANs, VLAN 100, 1 and 200. When I don't have any VLANs created, by default there is one VLAN. What is that? VLAN 1. By default, all the ports belong to VLAN 1. By default, all ports are in one single broadcast domain. What is that broadcast domain? VLAN 1. Later, what I did, I created VLAN 100, which means I broke down that large broadcast domain into one small piece called VLAN 100 and assigned this 10 ports. Again, I created another broadcast domain and took some ports from VLAN 1 and gave it to VLAN 200. So now the VLAN 1 members are getting smaller and smaller because I'm going to take them and put them in different VLAN. I said 5 departments, so already out of 80, 20 is over. And now I'm going to take another 6, 7, 8, 9, 10 ports. And I'll give this to VLAN 300. So now the number of ports from VLAN 1 is reduced. I have taken another 10. Now I'm going to take another 10. 4, 5, 6, 7, 8, 9, 10. Now these 10 I have taken. I don't want to take there. Let me take from here. 1, 2. These 10 ports. I'm going to give to VLAN 500. You see, all the other blue ports which are not in any other color rectangle, they are still in VLAN 1. Now I'm going to take another 10. Maybe here 6, 7, 8, 9, 10. That is in VLAN 400. So now 5 departments I have already taken, so the rest 30 ports are still in VLAN 1. Earlier it was 80 ports in VLAN 1. Now I have taken 50 ports for other VLANs. So totally now how many broadcast domain I have, 6 broadcast domain. In the beginning, it was only one. All were in one big broadcast domain. How big? 80 ports. It was very difficult to handle also. Now I have made them into small broadcast domains. By creating VLAN, what we do is we break down the big broadcast domain into multiple small broadcast domain. Now, if there is a broadcast sent to this port, it will be only flooded within these 10 members. Say, for example, a packet is coming for which there is no MAC address in the MAC table. What it will do? It won't flood to all 80. It will be flooding only within this broadcast domain. Now, what is VLAN? Breaking down large broadcast domain into small multiple broadcast domains. Traffic from one broadcast domain, in another word, traffic from one VLAN will not be able to talk, will not be sent, cannot be sent to another VLAN. Member of same VLAN alone can communicate. Members of different VLAN cannot communicate. This is as equal as having 5 switches, not 5, 6 switches, 6 physical switch. இருந்தா எப்படி வந்து ஒரு சுவிட்சில் கனெக்ட் ஆகிருக்கிறோம் இன்னொரு சுவிட்சில் தனியாக இருக்கிற இன்னொரு சுவிட்சில் இருக்கிறவனோட பேச முடியாதோ அது போல ஒரு வீலன்ல இருக்கிறவ இன்னொரு வீலன்ல இருக்கிறவனோட தொடர்பு கொள்ள இயலாது. Can't be possible. There is a true isolation. Not only that, creating VLAN increases the number of broadcast domain. By doing so, you can localize the impacts. For example, if there is a broadcast sent, as I told you earlier, that broadcast will impact only these 10 people, not everyone in the switch. Now, I would like to show you all that I have spoken. You see, I'm taking this first switch. In this switch, I have 24 port. How do I know? It is written here, 24 TT. You can also count these ports. It will be 24, okay? So I can see the number 24 here. 1, 2, means 1 on the top, 2 on the down, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Another 12. So totally 24. Now all these 24, if you notice, see inside the switch I am typing enable, and when I say show VLAN brief, this is the command, show VLAN brief. You can see there is a default VLAN called number 1 to which all the ports 24 fast Ethernet and 2 gig Ethernet, all these 26 ports are member of single VLAN. Now listen carefully. What I'm going to do is I'm going to take this first 10 port, put them in VLAN 10, and I'm going to take this next 10 port, put them in VLAN 100, and I'm going to take the next 4 port, put them in VLAN 200. Listen, how to do this. First you create VLAN 10. If you want, you can give a name, but it is an optional one. Name sales. So we have just created VLAN. Let me show you. Show VLAN brief again. You can see a new VLAN called 10 is created, but no ports are allocated. There is no port allocated. Can a switch be without a port? No, there should be a port. There should be some port. As we planned, we are going to take this 10 port and put it in this VLAN. How to do that? You can go one by one, interface F0/1, and say switch port mode access. I'll explain what this command means in another class. And then switch port access VLAN 10. What does this mean? You belong to this port. This F01 belong to which access port? VLAN 10 port. So can you connect this access and this access? Yeah, they are connected. We'll talk about this line later. It is not mandate that you should type this command before you type this. No, it's not a mandate. It's a good practice. So, boom. Now if you go back and check show VLAN brief, already one port is given here. Now how many broadcast domains are there? 2 broadcast domains. This is one broadcast domain with one port. This is another group, another broadcast domain. Now we have another 9 ports to repeat the same command. have interface of 0/2, switch port mode access, switch port access VLAN 10. Go and see if you want. You don't need to come every time and see, but I'm just showing you. You got another port from here taken and given here. Now I'm going to say interface F0/3. What is the command? Can anyone say? Mm-hmm. Mm-hmm. Exactly. Exactly. Next, interface F0/4, switch port mode access, switch port access VLAN 10. See, like this, you have to repeat 10 times if you want to bring 10 ports from here to here. Instead of doing like one by one, there is a way to go under a range of port like this. What are the other ports left? 5 to 10, right? See how I do. In one go, I can push it down here like this. Interface range F0/5-10. You see? And now I can say switch port mode access, switch port access VLAN 10. Boom. Now all 6 ports, 5, 6, 7, 8, 9, 10 are now member of VLAN 10. Let's go verify. Show VLAN brief. Look at this. Now how many broadcast domain is in this switch? 2. This is as equal as having 2 separate physical switch. If you have a computer connected on this port, another computer on this port, they cannot talk. You want to see? I'm going to connect. Take a PC, another PC, connect to, okay, let's use this cable, this one, connect to F05, which is in VLAN 10, another wire, connect to 12. 12 is not in VLAN 10. 12 is in VLAN 1. Let me show you that. 12 is in VLAN 1, the default VLAN. But this one which I connected 5 is in another VLAN called sales. Because they are in 2 different broadcast domain, even if they are in same subnet, you see, 10.0.0.1, and now 10.0.0.1, there is no need for gateway. Now, in this PC, I'm going to give 10.0.0.2, the very next IP, but they can't ping. Very next IP I'm giving, when I try pinging 10.0.0.1, no ping. Even from there, if you try pinging 10.0.0.2, no ping. Let's go to the switch and see the MAC table. Listen, show MAC address table. You can see the device connected on F012, MAC address is this. It is a member of VLAN 1. The device connected on F05, MAC address is this, but it belongs to different VLAN. They cannot talk. Even though the MAC addresses are learned, they cannot talk. You see? Switches cannot forward because according to the switch, they both don't belong to same logical switch. This is logical switch number 1. This is logical switch number 10. It won't allow them to talk. It won't allow. That's why the ping never happens. Now, if I disconnect this wire, now you see, I'm going to disconnect this wire and connect it to 6. See what happens. I'm connecting to 6. Then the ping will happen. Why? 5 and 6 are in same broadcast domain. How do I know? Show VLAN brief. 5 and 6 are in same broadcast domain. As a result, these two can ping. Let this come green. Wait. Now you see. Now you ping. The ping will definitely happen. When they are in same VLAN, they can ping because they belong to same group, same broadcast domain. Different broadcast domain, they don't talk. Now once again, I want to create another VLAN and show you VLAN 100. Name is optional. I'm going to say name protection. Now next is I would like to allocate port number 17 to 24 to 100. How do I do that? Interface range, port number 17 hyphen 24. I'm right now inside all these 17 to 24 port. You can see the mode. It is if range, interface range. And now what is the command? Switch port mode access, switch port access VLAN 100. 100. You want to go verify? The command is show VLAN brief. Look at this in production. Ports from 17 to 24 is moved in. You know, so this is one group. This group will never able to communicate with this group. They can't. Now I'm going to create another VLAN and put 11 and 14. See, it's not continuous. 11 and 14. See how to put the ports which are not immediate ports. I create a VLAN 200. I don't want to name it. I say interface range F0/11, comma F0/14. See, if they are not continuous port, you should put comma and put the next one which you want to put in the region. Whereas in the previous case, I put hyphen because it is continuous, 17 to 24. Whereas here, I put comma. Range, you can put RA or RANG, you know. You can press tab also, it will work. Now let us say switch port mode access. Switch port access. VLAN 200. Let's verify. Show VLAN brief. To VLAN 200, I did not give name, so it automatically generated a name. And then these two ports are moved from 11 is moved from here, 14 is moved from here. Now, how many broadcast domains we have? 1, 2, 3, 4 broadcast domains. 4 switch. It is as equal as you have 4 separate physical switch. Did you understand VLAN? You should do some VLAN, create some VLAN, allocate some interface to VLAN, and see whether it works. You know, try connecting PCs like this. Check. Members of same VLAN only should talk. Members of different VLAN They are not allowed because they belong to two different broadcast domains. I'll stop here.